Uh, so the next problem, x of t equal to sine omega t plus y, where y is uniformly distributed in 0 comma 2 pi. Show that x of t is wide sense stationary process. So given is x of t. X of t is a random process. Random process means random variable with the time t is random process. It is denoted as x of t. It may be a capital X of t or small letter x of t. X is a random variable, t is time. So x of t equal to sine omega t plus y. Sine omega t plus y is a random process because random process is a sine wave or cos wave. So we can put here sine omega t plus y, where y is uniformly distributed in 0 comma 2 pi. We have to prove that x of t is wide sense stationary. So x of t is stationary means we have to find the mean and variance standard deviation of x of t should be constant. That is statistical terms of x of t should be constant is stationary. Here we are going to prove x of t is wide sense stationary. That means we are going to enough to prove x of t with the mean, that is expression of x of t is constant and autocorrelation function or double x of tau equal to expression of x of t into x of t plus tau depends only on tau. So the given function, take x of t equal to sine omega t plus y. Here y is uniformly distributed random variable. So already we know that y is uniformly distributed random variable means here f of y equal to 1 by 2 pi. Because if x is lies between a to b, x lies between a to b, that is a less than x less than b, then uniform distribution f of x may be written as 1 by b minus a. If a is less than x less than b or a less than or equal to x less than or equal to b, we can write f of x equal to 1 by b minus a. Suppose if exists another limit function f of x may be 0. So this is uniform distribution. Here y lies between 0 to 2 pi is given. So the given term is x of t equal to sine omega t plus y, and y is lies between 0 to 2 pi with the uniform distribution. So refer uniform distribution. After that we can write f of y. Here y is variable. So f of y equal to 1 by 2 pi if 0 less than y less than 2 pi. Function is 0, suppose other limit exists. So this is uniform distribution definition. F of x equal to 1 by b minus a if a less than or equal to x less than or equal to b. Suppose f of x is 0, other limit exists. So small letter f of x means here probability density function. So here f of y equal to 1 by 2 pi based on this uniform distribution. So 1 by 2 pi if 0 less than y less than 2 pi. Suppose f of y may be 0, other function, other limit exists. So we have to find first expression of x of t. Expression of x of t based on the formula expectation of x. The expectation of x equal to, we can write integral minus infinity to infinity x into f of x dx. If x is continuous random variable, we can write expectation of x equal to integral minus infinity to infinity x into f of x dx. Similarly here, expectation of x of t equal to integral minus infinity to infinity x of t f of y dy. So here General limit is minus infinity to infinity. But our given problem y lies between 0 to 2 pi. So that we here substitute 0 to 2 pi is the limit. So x of t function is sin omega t plus y. F of y, f of y is 1 by 2 pi dy. So here 1 by 2 pi is a constant. So we can take outside from the integration. After that, the integral of sin omega t plus y value is minus cos omega t plus y. Because integral sin ax plus b dx equal to minus cos ax plus b whole divided by a. So here upper limit is 2 pi and lower limit is 0. So replace here y variable with upper limit 2 pi and lower limit 0. So 1 by 2 pi minus cos 2 pi plus omega t plus cos omega t plus 0. So this term equal to minus 1 by 2 pi into cos omega t minus cos omega t, because cos 2 pi plus theta equal to cos theta. So we get here expectation of x of t equal to 0, because here cos omega t minus cos omega t value is 0, that is equal to 0. So expectation of expectation of x of t is 0. It is a constant. Expectation of x of t does not belong to here t. It is a constant. So expectation of x of t equal to 0 or 1 to 3 consider as constant. Here we get expression of x of t is a constant term. So next we have to find the autocorrelation. Autocorrelation or double x of tau. Here tau is the time difference, t1 minus t2 or t2 minus t1 denoted as tau. Here autocorrelation denoted as r double x of tau. Sometimes it is r x of tau. Sometimes it is denoted as r of tau. Whatever it is, the three types are called autocorrelation symbol. So here r double x of tau equal to expectation of x of t into expectation of x of t into x of t plus tau. T plus tau. Already we know that x of t is a given function sin omega t plus y. Here x of t plus tau means the smallest increment with the time t. So sin omega t plus tau plus y. Here t replaced with t plus tau. So we get sin omega t plus tau plus y. So this term equal to 1 by 2 into expectation of cos omega t plus y minus omega t minus omega tau minus y minus omega t plus y omega t plus omega tau plus y. That means 2 sin A sin B. This is a sin B. 2 sin A sin B equal to cos A minus B minus cos A plus B. Based on this formula, here we write 1 by 2 into expectation of cos omega t plus y is A minus B means omega t minus omega tau minus y minus cos A. A is omega t plus y plus B is omega t plus omega tau plus y. So this term equal to 1 by 2 into expectation of cos omega tau minus omega cos 2 omega t plus omega tau plus 2y. Because here minus omega t and plus omega t get cancelled, minus y and plus y get cancelled. We get here 1 by 2 into 1 by 2 into expectation of cos of minus omega tau. We know that cos of minus theta equal to cos theta. So that we get here 1 by 2 into expectation of cos omega tau. 1 by 2 into cos omega tau. Here is minus omega tau. Based on this definition, cos of minus theta equal to cos theta, we get cos omega tau. So 1 by 2 into expectation of cos omega tau minus cos omega t plus omega t is 2 omega t, y plus y is plus 2y plus omega tau. So we get here 1 by 2 into the expectation of cos omega tau minus cos 2 omega t plus omega tau plus 2y. That is equal to 1 by 2 into expectation of cos omega tau minus 1 by 2 into expectation of cos 2 omega t plus omega tau plus 2y. Here expectation of constant equal to constant. So that here there is no y variable. So expectation of cos omega tau can be written as cos omega tau. So 1 by 2 into cos omega tau minus 1 by 2 into the same term, expectation of cos 2 omega t plus omega tau plus 2y. Consider this equation as equation A, because the expectation of one variable exists in that variable. So expectation of x, the expectation of x means integral minus infinity to infinity x into f of x dx. Similarly here, the expectation of x means cos 2 omega t plus omega tau plus 2y into f of y dy, because y is variable here. Here basic general limit is minus infinity to infinity, but y lies between 0 to 2 pi. So substitute integral 0 to 2 pi cos 2 omega t plus omega tau plus 2y dy. So 1 by 2 pi is the f of y. F of y is 1 by 2 pi. This is constant. So taking outside from the integration term, 1 by 2 pi integral 0 to 2 pi cos 2 omega t plus omega tau plus 2y into dy. This can be written as 1 by 2 pi integral cos 2 omega t plus omega tau plus 2y dy means sin 2 omega t plus omega tau plus 2y whole divided by 2. This is variable coefficient. Y coefficient is 2, so that we can write denominator term is 2. So the lower limit is 0 and upper limit is 2 pi. So 1 by 2 pi into 2 means 1 by 4 pi into sin upper limit is 2 pi. So substitute 2 pi with the variable y. So we get 2 pi into 2 is 4 pi plus 2 omega t plus omega tau minus lower limit is 0. So sin 2 omega t plus omega tau plus 2 into 0 is 0. So 1 by 4 pi into sin 4 pi plus 2 omega t plus omega tau minus sin of 2 omega t plus omega tau. That is equal to 1 by 4 pi into sin 2 omega t plus omega tau, because sin 4 pi plus theta is sin theta. So that here sin 2 pi 4 pi plus 2 omega t plus omega tau means sin 2 omega t plus omega tau minus sin 2 omega t plus omega tau. Here opposite signs are exist. So we get expectation of cos 2 omega t plus omega tau plus 2y value is 0. So substitute this value in equation number A. So we get r double x of tau equal to 1 by 2 into cos omega tau, because expectation of 2 omega t plus omega tau plus 2y equal to 0. Consider this as b. Substitute this value in equation number A. We get r double x of tau equal to 1 by 2 into cos omega tau. So that r double x of tau equal to 1 by 2 into cos omega tau. That is depends only on tau. So the two conditions to going to say WSS means expectation of x of t equal to 0 or expectation of x of t equal to constant. Expectation of x of t equal to constant. The autocorrelation function or double x of tau depends only on tau. Here two conditions are satisfied. Here x of t is a wide sense stationary process. X of t is a random process. We are defined here x of t is wide sense stationary process because the two conditions expectation of x of t equal to constant. Second one, the autocorrelation function or double x of tau depends only on tau, or double x of tau may be written as expectation of x of t into x of t plus tau. Substitute the functions and simplifying we get depends or double x of tau depends only on tau. So that x of t is a wide sense stationary. Thank you.
Sorry.